right, so any questions from homework? Yeah.
From the chapter 1, it was like the nuts and raisins.
81
From
from the review?
Yeah, from 125.
Thank you.
But they didn't really ask what it was.
Oh yeah, it says what quantity of nuts and raisins should you use? So the weird thing about reading through that problem is buried inside is what you want to have happen. So this one says the owner of a store sells raisins for $3.20 a pound. And nuts for $2.40.
What number is it?
81.
Yeah, number 81. This is page 126. He decides to mix them and sell 50 pounds of the mixture. So he wants to mix them. 50-pound mixture. Where do we go? For $2.72 a pound. The very exacting science of the raisin and nut industry. Now, it makes sense. If you're going to mix those, whatever the mixture price is going to be, it's going to have to be some price between these two, right? If you just put a few nuts in, it's going to be really close to $3.20, but it's going to be a little below. It's sort of like diluting this a bit. Does that physically make sense? So you can even see in your mind's eye, he's mixing these nuts and raisins. How important is that? Not really, but it's the idea of diluting it. This price is in the middle. It's not exactly in the middle, so it doesn't use the same amount. If you use the exact same amount from each, then it makes sense the cost of that mixture should be the average of these two. That is not the average of those two. What's it closer to? Which price? Yeah, it's 48 away from this, but it's only 32 away from that. So they're going to have, he's got a few more nuts in there than raisins. Right? Cool. So how in the world do you set this thing up?
Systems of equations.
You could do a system of equations. That's a beautiful way to do this. Yeah.
Table.
You could do a table. Yeah, so you set up like, let's see if I remember. Amount, rate, and then, whatever the hell you call it, tops, it almost doesn't matter. And then I used to always call this one the solution. So if you set up a table, you would say, all right, raisins, nuts, and mix. All right, I know I got 50 pounds of mix. So the beautiful thing about a table is you just start filling in what you know. And it costs, I want it to be $2.72 per pound. So how much total money will it cost for the mixture? If I wanted to buy the whole thing, I just really want some raisins and nuts.
136.
So if you multiply those two, you get
136.
136. All right, I'm a trusting fool, I believe. And what do we know of the raisins and the nuts then? You can either do the systems of equations, which is not bad. But to me, I always like to go straight to it. I mean, how many pounds of raisins does he use? And I love this question. You can tell me the answer. You can't give me a number, but how many pounds of raisins did he use? X. I love it. Right? He used X pounds of raisins. Now, you can't put an X here also, right? Because that would imply what? What would that mean? Same amount. We already just said it can't be the same amount. This is not the average of the two prices. It doesn't make any sense. And then if you want to do systems of equations, you could use Y there. But a little more direct. If that's X and the total is 50, what must this be? 50 minus X. Cool. I've got 50 total. I took X and put it there, so what's left? The 50 minus X is left. And then you do exactly what we did here already. What's the rate for the raisins? 320. The nuts, 240. So it's the total price of the raisins that's in the mix. I love it. 320 per pound, X pounds, so it's 3.2X. What about the nuts? 2.4 times the pounds there. hopefully this kind of problem you've done before. Many of you probably have done it like this. Some of you might have just done it straight up like a, if you want to go directly to a system of equations, with systems of equations you almost always have an easy equation and a harder equation. The easy equation is almost always a total amount, right? You have nuts and raisins. If I add the amount of both, I better get 50. I love it. I do that question as check to make sure everybody's with me, or at least looking this direction. And then the second one is the more complicated one. For every pound of nuts, it costs $2.40. For every pound of raisins, it costs $3.20. And if I add the costs, I should get, this is where it gets a little more confusing, $2.72 per pound for 50 pounds, right? So when you look at a system of equations, if I'm adding total cost to total cost, I better end up with total cost, right? Price per pound times pounds, price per pound times pounds equals price per pound times pounds. People always make a mistake, leave that 50 off. Well, that's difficult to do. You can't make this equal to 272 very easily. I don't know if you guys see that. I need this number to be big so I can equal this easily. But if you look, if I just solve for n or r, I basically get the exact same thing going here. This plus this equals that. That's my equation. Get the same equation either way. Went a little quickly through that because that's the review question. Right? Some of you should be coming out of algebra able to set up one way or the other. Or even a third way. You have a third way to do it. As long as it's legal, it's fine. My way to do it, Jeff, is make my older brother. Took this class already. Any other, is that cool for that question? How do you solve that equation? I mean, I basically end up with that. And now to solve this equation, you should just be able to attack that. Right? Sink your teeth into it. Getting there was the hard part. Solving it should be easy. Should be. Any other questions from homework? Yeah. Yeah. Yes, you.
Okay, 33 on 2.1. From page 150.
Okay. Oh, yeah, good. This just looks a little strange as to what they're asking you to do. So they give you f of x is x plus 4. This is page 150. Section 2.1. Number 33. This dude here, right? And then they ask you these weird things. What's f of x squared? And what's f of x squared? Right. Just saying it sounds like the same damn thing, but obviously there are very different ways of doing each of these. Right? What does this one want you to do?
Square the x in the equation.
Yeah, what does it want you to put into this function?
X squared.
X squared. So if f of x is x plus 4, f of x squared is x squared plus 4. I love it. Just follow the rule and put that in the right place. Now what's the second dude tell you to do?
Square the whole equation.
Yeah, take f of x, which is x plus 4, and square it. So replace this with what it is. What is f of x? X plus 4. And then square it. And what they're trying to get you to realize is, do you get the same thing?
No.
Hell no. Right? Squaring the result is not the same thing as squaring the input. Yeah.
Do you do number 75, the relativity question?
Yeah. Is that cool?
Yeah.
Okay. So when you first look at it, I think it might look a little weird what they're asking you to do. Okay. Relativity, I love it. 75?
Yeah.
So we got this here? And you look at that question and you wonder, was there a prereq of physics on this class? Everybody's thinking of quantum mechanics, right?
Yeah.
Good. All right. So should we go? But no, I like to throw a problem like this. I mean, they're here. you can do a lot of the math from all these different subjects, physics, biology, whatever. You might not understand what went into creating the equation, but they just want to show you. Here's an equation from physics that describes, in this case, it's how much a length changes based on how fast you're going. So if you're going damn fast past me, you look shorter than you actually are. You know, this direction, whatever direction you're moving in. That's a neat effect of relativistic speeds if you're going really fast, right? And I love the looks I'm getting right now. Just get to the math. 75 says, here's the function. The length at a velocity is equal to this. So originally the length is 10. And then you're going to make this thing go really fast. So this is true even if you're just going along in your car. But the speed you go in your car compared to the speed of light, they're not really, this is effectively zero. You got to be going pretty damn fast to see any actual change. All right, now how much of that do you actually have to understand? None of it. Because all they really want to show you is these are real life equations. Can you just plug stuff in? So if I sent this thing 10 meter long, whatever. One of my old professors, he was Swiss, and every other word was the F word. It was really, he was like always angry, you know. But he says one of his problems was Otto is carrying his ladder. It's 10 meters long, but the barn is only 9 meters long. How fast must Otto run so it looks like it fits? Right, so you have to shrink the ladder down to 9 meters. That was one of his favorite problems. So this is sort of related to that. All it wants you to do, c is the speed of light, so they tell you c is this. Light goes damn fast. And then part A just says, and in fact you don't even need that based on how they tell you this. Find L of 0.5c. Now let me just ask you right now, what does that mean?
Half the speed of light.
Half the speed of light. I love it. And the beautiful thing about that is they didn't have to tell me the value of c, because they're giving it to me in terms of fractions of c. So what happens, take a minute, if you haven't done this problem yet, and just try to plug that in. Try to simplify it. Something really nice should happen. Just try to plug that in and see what happens. Right now. Not later. Of course, this is a function of v, so that value is going to go in for v, the velocity. Alright, so what do we get here? Let's see. If I do this, plug in, there's 10, 1 minus, plug in 0.5c for v. So I get 10 squared root of 1 minus, what's 0.5 squared?
0.75. Wait, 0.25.
0.25, I like it. That's good, quick adjustment. Then you get c squared over c squared, of course the c squares cancel. So you get 10 square root 1 minus 0.25, you just had ESP. You were ahead of everybody. 1 minus 0.25 is 0.75. And you can just plug that in the calculator. It's 10 square root of 3 over 2, so it's 5 square root of 3, so it should be like, what is it now?
8.67.
8.6 of it, so about 8.7. So if you sent something that was 10 meters long, and you sent it going half the speed of light, it's going to actually look like, to somebody standing still as it goes by, it's going to look like it's 8.7 meters long. That's the effects of traveling a decent fraction of the speed of light. It's really neat. Time also changes when you travel the speed of light, but I've never done it, so I can't give you personal observations. Again, did you have to know any of the physics behind all that? I know I went into it, and some of you guys tuned out, and I don't blame you. Do you have to know any of it? No, it's just plugging that in. The C's cancel, I love it. They don't even have to tell you this. So some of you might screw up by trying to use this number. You don't have to use that number. The C's are going to cancel. So then the next few the same way. What if you go 3/4 the speed of light? What if you go 9/10 the speed of light? Plug those in. See what happens. And of course, part B is going to be easy. Once you see how, if you go faster and faster, its length is going to get smaller and smaller relative to us. Good. Is that a problem? Cool. That's just a plug and chug problem, really. Don't let the physics freak you out. Hopefully some of you are actually interested in physics, but if you're not, it's okay. Any other questions from homework? Okay, so I'll take that as a good sign. Yeah.
86 from chapter 1.
86? The one about the gardens and the homeowner? Yeah. So 86 is page 126. They want to fence in 3 adjoining garden plots like this here. Look at it from overhead. One for each of her children. Okay. If each plot is to be 80 square feet in area, so each of these is 80 square feet. And she has 88 feet of fencing material at hand. What dimension should each plot have? Do any of you guys do any work like that? Do you do any fencing work? Do construction kind of work? Okay. So you know how it gets weird with requests of how to shape things or what to do with things. Yeah. So this is something normal that you would hear. And they want to drop their kids in their gardens and let them chew on their carrots so they can go do whatever they want to do. Kids can't get anywhere. That's the way I'm thinking of it. How does that relate to the picture? How does that number there relate to this picture?
It's all edges added together.
Exactly. So you can't really say perimeter because I want to actually include also the middle. That's what the perimeter would leave out. So all these things added together must be 88. So if I could just give them all names, I can then set up an equation. Right? So, what names are you going to give these things? And what's this going to be here? 11, so we'll call it W. Right, and this here, that's crazy. So L, L, L for each of those, is that cool? So this is L, 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 this is W. So what's the complete, and of course in here, those are going to also be W. Bless you. This is the power of drawing a picture. A lot of us skip the picture. If you skip the picture, you can very easily skip those other 2 W's. Right? You can lose something, and then you get these weird-ass answers. What equation can I set up now? 2 equations, actually. I have a perimeter kind of idea, including the 2 in the middle, and I have an area kind of idea. So what's the area equation that we can set up? Almost too easy. W times L equals 80. That's craziness. There's 1 equation. And why do I need 2 equations here? Why do I have to have 2 equations? How many unknowns do we have? 2. So if I have 2 things I don't know, you better be able to set up 2 equations to solve them, right? If I have 1 thing I don't know, I just need 1 equation. If I have 18 things I don't know, I better have 18 independent equations so I can figure out what it is. Do any of you guys do any matrices and stuff in Math 110? Or wherever the hell you came from. Right? Maybe some of you guys came out of high school, you did algebra high school. Or at least systems of like 3 equations, x plus y plus z equals 7, x plus minus y plus 2 z equals 8. Does that sound at all familiar?
Yes.
Alright. Matrices is kind of like a shortcut to doing all that by hand. So if they didn't show you matrices, I'm sorry. Some of you guys don't like matrices, and I understand it's one of the major hated things, but what's the other equation I can set up?
For W.
Good. 1, 2, 3, 4W plus 6L
88.
equals 88. I love it. Cool. Now between these two, you should be able to solve for W or L. Right. So you can either solve this for L and plug it in here. I'd rather solve this one for W or L and plug it into the other one. Go ahead and try to do that. See what you end up with. There's a certain kind of equation you have to be able to solve to do this problem. Let me catch up with you guys. I think my suggestion, how many guys, did anybody solve for W? Hopefully a few guys. I would rather solve for W, it doesn't really matter, but if I solve for W, 88 subtract the 6L over, and then of course divide by 4 to get W by itself. You can reduce this a little bit. All the numbers are divisible by
4.
not quite 2. It still looks kind of gross. And then what can I do with this now? Why the hell did I get this?
Times it by 2.
Well, that'd be kind of going backwards, but I can take this W and plug it in here. That's how you do systems of equations, right? The most basic way to solve a system is a substitution. Solve one equation for a letter, plug it into the other equation. So what do you get when you do that? What do you get when you plug that in? Plug this in here. What do you get?
44 minus 3L times L.
I love it. Cool. And now how do you solve that thing? What kind of equation are you going to end up with here? What's that word? Quadratic. I love it. So you're going to end up with a quadratic because when you multiply this L in, you're going to get an L squared. You're going to have a quadratic equation. Oh, shit. And how do you solve that kind of thing?
Square root.
No, you can, as long as there's no other L's running around. Unfortunately, there's going to be more L's running around. Damn. So I can't get L squared by itself. I can't get the L's. They can't go together. So hopefully I can either factor it or... Well, let's see. Let's get there first. How do I... What's a really good first step here?
Times L.
All right, distribute the L. I could also
Times
multiply both sides by 2. If I distribute the L, I get 44L minus 3L squared. Multiply by 2, I get 160 over there. Just multiply by 2 because I don't like that fraction in there, right? If I have an equation, I can kill any fractions I see.
You move the 160 over.
Well, multiply both sides by 2 and they gave me 160. Oh, now I can, yeah, okay, gotcha. Now I can move the 160. To be honest though, knowing what I'm going to have to do, I'm going to try to either factor this thing, I'm going to try to factor it first. Quadratic should be your last resort. I'd rather have the first dude positive. So I'd rather move stuff that way. Yeah. So I'll end up with positive 3L squared minus 44L plus 160L.
Equals 0.
That should be second nature to you guys. Whenever you have a higher power than 1 in your equation, you want to get it equal to 0. I can't remember if it was here or the other class I'm teaching. Real quick side note on that. I saw way too much of this kind of thing. Okay, what mistake have I made? Or is there a mistake? Maybe it's a trick question. No, maybe it's a double trick question.
Have it fully solved for X.
When's the only time you can do something like this? Do one of these numbers have to be 4? If I say 2 numbers multiplied by 4, they go, well, one of them's got to be 4. If somebody said that to you, you have 2 numbers, they multiply to be 4. Does one of them have to be 4? No. Does one of them have to be 2? No. Does one of them have to be anything? No. Right? You guys with me? There's an infinite number of answers to this. There's no specific thing. The only number here that makes it specific is 0. If 2 numbers multiply to 0, one of them's got to be 0. Right? The only way you can multiply against 0 is if one of the things you multiplied was 0. So if it's equal to 4, that sucks. Some crazy bastard factored too early. You got to multiply this thing back out, subtract the 4 over, get it equal to 0, then refound shit. Right? That's the kind of problem I hated when I was doing algebra way back when. Because it almost felt like, damn, they factored, but they factored too early. I got to multiply that back out, bring the 4 back over, refactor it, because it's not equal to 0. Can't go anywhere. All right, no good. Let's be careful about that. Here, I'm good. Equal to 0. How do you try to factor this thing?
X is X minus...
Oh, let me catch up. What's your steps to try to factor this thing? What's your first step here to try to factor this?
See what adds up to negative 44.
And multiplies to be what?
160.
No. Yeah, can you divide everything by something? No. 3 won't go into 44 or 160. Right? So you can't divide by that. That sucks. When this number's a 1, it's easy. You just find that the numbers that multiply this add to be this. When that number's not 1, do you guys know what to do? And this is that factoring handout that I put up on the website if you want to print that out. It's got all the steps. So maybe we should focus on this for a bit. Does this sound familiar at all? Take the 3 times 160 to make 480. You find factors of that make 44.
X.
Magic X.
Second.
Isn't it called like the Magic X? Where you just...
Oh, dude, it's given so many names. It's insane. I call it surefire method, so that's what it was called when it was taught to me. So there's master product. This is the first I've ever heard Magic X. Why not? Right? And you're like, if it's so magic, why can't I just do the problem for me? Damn. But now and here's another thing. I think I told you this before. You don't have to start. How long of a list of factors do you think? 480 is a nice number. There's a billion different ways to break it up. So in reality, for this problem, it's an evil number. There's so many freaking ways to break it up. So I would much rather, what 2 things do I need these numbers to do? Multiply be this, add to be that. So I'd rather start with that. It's easier to make 2 numbers add to be negative 44. I can do that. 40 and 4, there you go. If they're both negative, they'll make a positive when they multiply, and they'll make a negative when they add. But what's wrong with negative 40 and negative 4? Do they multiply to be 480? Hell no. So I'll try again. Give me 2 more that add up to be 44. Yeah, okay, good. I like it. Negative 22 and negative 22. What do you get when you add and when you multiply those? We're close. 484, is that right? I like it. 20 and 24. It makes sense because it ends in 4. Right? I want to make these things add. And it also ends in 0 is what I'm trying to say. When you multiply those, it ends in 0. That's a good thing to kind of look out for. Do you guys see what I'm saying? Anybody ever show you this? Any of you not have a clue what my point is here? I mean, when you're taught how to factor, you're so focused on, when the teacher talks about it, they're so focused on finding a list of factors and then check to see if they add. Who the hell said they had to multiply correctly first? You just want the two numbers to do both. Who cares if you get them to add right? We get a list of things that add right, and I'll check to see if they multiply. And then I'll stop. There you go. Those multiply to be 480. I got it. Right? Okay, maybe. So many guys, I know there's a lot of little offshoots from this problem, so don't feel like, good Lord, this problem is long as hell. No, I've been doing all this other talking about stuff. This problem isn't that long. Now, how the hell do I use these numbers? I found the right numbers. What do I do with them?
Or negative x's.
Good. Break up the middle term, right? Because what's the easiest form of factoring besides GCF? What's the easiest form of factoring? Grouping. So I have 3 terms right now. The whole purpose of Surefire, what I call it, is to make 3 terms become 4 by breaking the middle dude up. Once I have 4 terms, I can group. And the only numbers that will make this grouping work are the ones that do the right thing here. I can break 44 up into 40 and 4, but the grouping will never work. It's only if they happen to multiply by this also, then the grouping is guaranteed to work. So I take this equation, and I break up the middle term. What do we got? 20 and 24. Alright, so in one sense, I haven't done a damn thing. Yay, Jeff, 44 is 20 and 24. That's the way to go. But in another sense, I've done a lot. I've taken it from a 3-term dude that's got the trial and error or whatever, and I've taken it to a 4-term dude, which is grouping, which is easy. So you group them. Comes out of these two?
3.
No. L? 3L minus 20. What comes out of these two?
Negative positive.
It's really cool, by the way. You know you want to have a 3 end up in there, don't you? You can't do the last step unless these two things here, the two parentheses dudes, are the same. If you want to have a 3 there, you know you have to have an 8. In fact, even better, negative 8 come out. To force this dude to be 3L, 160 divided by negative 8, negative 20. I'm pretty sure it was this class I saw way too many of you putting this down and then somehow doing the next step. I'm not sure. Now that, to me, is magic, right? I cannot do the next step unless these are the same, because the next step is GCF. If these are the same, they can come out. If they're not the same, you made a mistake. You don't just throw everything down there on the next step. So this is trying to tell you, oh shit, you divide by negative, they should be negative. These are the same, so it can come out. So I am not here to reteach you factoring, but I am definitely here to help you remember how to factor. So you can always ask me questions about how to factor, because factoring is stupid important. Right. To me, Math 88, you learn how to solve equations. 90 and 110 really is all about firming things up and learning how to do word problems and a little bit of graphing. Here, factoring you should have down. Right? Math 110 is where you really learn to factor. That's the most important thing to come out of there, is how to factor. Now, what's the next step here? Yeah, set them equal to 0. Add 20, divide by 3. So L is 20/3, or L is 8. Now, don't just circle that and go on. Come back to what the hell the problem was. Right? Well, if L is 8, one set of answers is, if L is 8, what's W got to be? 10. Cool. So L 8 feet with 10 feet for one little plot. And the other possible set of answers would be L is this disgusting 20/3. Then what's W got to be? To multiply to be 80. So if you just plug in 20/3. Multiply by 3, divide by 20. 4 times 3 is 12. So those are the two possible setups that will get you the same area that you want. How we doing there? Is that right? Kind of makes sense, right? You can either have a long, skinny one or a fat, short one, and they both have the same area. That's entirely possible, so it makes sense. Okay. All right. Any other questions? Okay. So let's do this. Let me turn this to you on. Now, on the survey, and this class is the one most of you guys filled out that survey. That's really cool. If you haven't done that survey yet, do it soon. It just helps me see what's going on with the class, what your future plans are, that kind of thing. I only made 30 of these since I just remembered right before class to make them. But I don't think a lot of you guys need this. This is really kind of like a basic outline of how to do certain things. A lot of you guys said you'd use a graphing calculator a lot already. So this is actually a handout that I give to my 110 students after about halfway through the semester for all the graphing stuff we've talked about. But as you come to your row, let me know if you really, really want one of these. I'm going to post it up on the website too if I run out. Who here really wants one? 1, 2, 3. This right here. 1, 2, 3. You guys. 4. You guys here? You guys. You guys here?
Can I get one also?
Sure. Those would be cool. Use those.
Where do I find that term for the calculator on the computer?
Oh, it's on my website, right on the first page, right near the top.
No, the one you use.
Yeah, the one for Android phones.
No, the one that I can.
Oh, I see. You gotta have a lot of money. These are not cheap. I was considering. I just yesterday found. Any of you guys ever go to that website Reddit?
Yes.
All right. I'm a hardcore Redditor. There's a lot of cool subreddits. Obviously, I hang out a lot with math education, with a lot of the other stuff too. Somebody posted a link to an emulator you can use that's free. The steps are a little involved, and I want to download the stuff onto my own computer so that it's there, so that if they change it on the other side, it doesn't freak us out. But as soon as I do that, I'll put a link up. So no matter what, you can put that on your computer. It's not something for your phone, though, right? It's not going to obviously help you out in class.
Have you used Microsoft Mathematics before?
Do it again?
Microsoft Mathematics?
I don't think so.
I'll show you after
Oh, okay.
class. It's like a calculator thing.
Cool. Okay, so a couple of the very, very basics very quickly. So you never really used this thing before. And there were about 6 of you that said you had never really used this before. Hopefully you've used like a scientific calculator before where it shows you, as you plug it in, you can see everything you've done. So it's a lot nicer than just your basic 4-function little thing where you got to remember what you plugged in. It's just horrible. And if you here's something some of you guys might not know. If you hit second enter, you can go back and make changes. So if that was supposed to be divided by, that kicks so much ass when you have this long string of stuff and good lord, kick ass. I don't need that. I'm not used to that. Okay. Now some of you guys, if you have an older one of these, an older TI, your square root sign doesn't grow. You have to actually open a parenthesis and then close it at the end of your square root. The newer ones have the square root sign that grows, so you can see exactly what's under the root. So the old one kind of sucks. You got to be careful with the parentheses. So if you did this and you're like, oh, well, it's not real for one thing, Jeff. That's the problem. Pay a little more attention. So you did this, so it's not real. So I go over here and I say, okay, this is supposed to be a plus. Bam. So you hit second enter, it takes you back to the last thing you put in. If you hit second enter again, it takes you to the thing before that, second enter, the thing before that. It's kind of nice. I forget how many you can scroll back through. Because there is no scroll button on here, unfortunately, right? Everybody's always looking for the scroll button because they're so used to, on the computer, being able to scroll up and down. You can't do that on this. But you can at least do second enter, which effectively is like a scroll back. I think on the new ones you can do a different way, but I'm not.
You can just press up.
Really? I'm still not used to it. Oh, cool. Up is even better. You can't do this on the old one, so if you have a square root key that doesn't extend, you can't do what I'm doing right now, because actually this is something I just learned. Because I haven't used the new ROM yet. So you can just hit the up arrow so I can do that. But the old way you always use second enter. It takes you back to previous stuff.
Is that like a, is that through the computer, or can we like update our calculators?
You should be able to, if you can hook your calculator up to the computer, if you have the cable, you should be able to go to TI's website and get a new ROM installed on your calculator, so it'll do this. So it's not like they made any major hardware changes, they just made a software change. So you should be able to hook up to the computer, go to the website, download this stuff, and put it onto your calculator. Yeah.
It could go at least back 20 problems.
Sweet. All right. Let's see what else I want to tell you about. Oh, real quick. If I do, you see how there's a negative button and a minus button? Those are different. This does mean negative, and this means minus. If you mix the two up, the calculator will either freak out. If you hit go, the really cool thing about errors is if they give you a go-to option, you say go-to, it'll put the cursor right on top of the problem. Like, oh crap, I used the wrong minus button. There you go. Let me think. What else might you be? Oh, temporary memory. If I do something like this, 89 divided by 78, I get this rather long expression. And then if I have to square root that, I don't want to retype all this stuff. So if I hit square root, and by the way, the second button is like your shift button. Second square to get the square root. Second negative for ANS is ANS stands for answer. So it's always the last thing that was on the screen. So it's constantly changing. It's like truly temporary memory. So if I want to take the square root of this number, I just hit square root answer. And I get the square root of that number. So now ANS holds this number in its memory. Okay, cool.
You can also press up and then enter and it puts it inside.
Oh, sweet. Look at all this stuff I'm learning. How many of you guys have, if you hit the square root, everybody hit your square root button that has the calculator. Now, how many of you guys does it look like this? And how many versus, now, let me try it this way. How many of you, when you hit the square root button, it has a parenthesis in there? All right, how many guys has it look like this? There's no parenthesis, it just looks like this. Okay, gotcha. About 4 of you then have the newer ROM, the newer software that'll let you do this. So it sounds like, let me see. Oh, I see. Cool. Oh, that kicks so much ass. So now that's even better than temporary memory. You just got to go back up to whatever number you want to. Okay, I'm geeking out now. Let me see. Anything else I didn't tell you? Oh, one last little thing. If I wanted to use this number, if I wanted to, let me think, do several things with it, I could store it. See this little button down here? STO. Store it. Right here is your quick access variable button. Store it in X. So now X has that value. So if I said 4X, it'll do 4 times 1.068, blah, blah, blah. So that's cool. So now X has that value for as long as you want it, and then you can just change it whenever. All right, cool.
You can do it again with the answer and then.
Oh yeah, so if you do something like you do 7 divided by 65, and then you have to do several more things with that number, you can store it. Hit store right there, stow, X right here. It's your general all-purpose variable button. So now X has that value. So now if I want to do 8 times that minus the square root of that, bam, right? Instead of doing that whole number over and over and over again, I can just store it somewhere. Now notice, see all the green letters? Those are all memory locations, so you can hit, if you want to store it in one of these green letters, you hit stow alpha and then pick a letter. And then that letter will hold that value. You guys kind of with me? Okay. I don't want to get too deep into this. I want to let you guys play around. And a lot of you guys, this is old news. A lot of you guys have used this a lot. Okay. Anything else specific before I get into some graphing stuff? Okay. So the real basics on graphing. Obviously, just about the most important button for graphing would be up here, the y equals. So you really can only graph true functions. Something you can actually solve for y. So the only way you can graph like a circle is to graph the upper half and the bottom half separately. And then the graphing calculator actually has some trouble connecting it. Right? You can only calculate so many values. So if I wanted to graph, everybody go to y equals. And do me a favor, if you're borrowing one of mine, you might have some stuff in there, so go ahead and clear that out. So if you got some stuff somewhere in here, just hit the clear button. Clear it all out, make sure they're all empty. You got like 10 of these things, all right. So you can actually graph 10 different equations at once. So it's all graphed. Now here's a cool one. Go to math. And so I'm definitely not going to go over every damn thing this thing can do. That would be sort of a week-long course in the calculator. But I just want to do a few things just to show you. I mean, if you look through this list, you can try to figure out what these things all do. That first one seems very interesting. So convert to fraction. That might be useful. If you come over here to num, the very first dude, what would that do? Absolute value. So if I select that thing, here's an absolute value. Now if you have the old version, it's going to say ABS parenthesis, right? You guys, and then you just plug in whatever and when you close the parenthesis, that's when you come outside of the absolute value. So you never want to close a parenthesis in the old style until you're done. So you don't want to close the square root parenthesis until you got everything in there that's supposed to be under the square root. That's why the new dude is so much better. You can actually just see what the hell's in there. So if I put in here x minus 5. So I want to graph the absolute value of x minus 5. Now somebody tell me, where is that equal to 0? Yeah, when x is 5, this is 0. So this is going to be the V shape. But it's going to be 0 at 5. So it's going to, for you guys, it's going to move this way. Yes, ma'am?
Is it going to be the x that you saved, that you stored?
No. I love it. So thank God the calculator is able to tell when you're on the home screen, you mean memory location.
Yeah.
When you're in the graphing screen, you mean variable.
That's cool.
Yeah. Thank God. So if you hit graph right now, let's see what happens. Some of you guys might have very strange things happening. If you're playing along at home. Anybody not have this picture up there? Everybody's got that picture up there? That's crazy. Alright, I thought for sure something weird. So if you don't have that picture, if you had something like this, go look. You graph it and it looks like this, let's say. Alright, that's funky as hell. So that means that I just changed the window. I'm looking at a different part of the graph. So normally the graph starts with negative 10 to 10, negative 10 to 10. And that's what you can see. It's like a little porthole window. Well, let's say your stuff's happening over there, so you want to be able to see over there. Right? So right now, so anytime I put a new function in, I almost always do zoom 6. Standard zoom. So take it back to negative 10 to 10, negative 10 to 10. It's a good place to start. How are we doing so far? Okay, so let's do two things that are very technical. Let's do a parabola and find the roots. And then we'll solve an equation graphically on the calculator. All right, let's try those two things. So let's go to y equals again. Clear this absolute value thing out of the way. Oh, somebody wants this. Somebody must have left this, so definitely give this back to me. But somebody want to borrow? Nobody wants to borrow that? You're all like, I don't know what they were doing. I don't know if they washed their hands. Point. So let's all put in here the same kind of thing. I want a downward-facing parabola. So what do I definitely have to make sure happens? Negative x squared. Good. So let's do negative x squared plus 6. Let's do that. Let's make it even funkier. Minus x. I like it. Let's see what happens here. Sweet. Of course I made something. Oh, that's right. That's what we got. So the way to find roots, if I wanted to find exactly what that root is, and let me change this a little bit, because I actually made something that's factorable, so that's not really too exciting. Make that 6 into a 7. So go in there and I'll just officially say that's our editing time. So go in there and make that 6 into a 7. So we got that? Hit graph. Alright, so now we got a little bit more disgusting roots. So since that first thing I put in, it was actually factorable, believe it or not. So the roots were like 2 and negative 3 or something easy. I want them to be a little more disgusting. So I can't factor that damn thing, but the graphic calculator can eat this up. It's going to be able to find the roots. So where are the roots at?
They cross the x-axis.
Beautiful. When they cross the x-axis, because that's where the roots start on plants. So that's why we call these roots. We also call these zeros, which makes sense. They zero out the function. They have a zero value there. So here's how you find, let's find this root here. So if you go to second trace, and real quick, just to show you, oh, I put it on here. No, I didn't put it on here, did I? Changing the window, graphic basics. I don't think I put the roots on here. Oh, good thing we're doing it. We're going to do this one next, part C. Obviously, I want to use the second dude here, the 0. And it's going to ask you 3 questions. What is your favorite color? No, it's going to ask you left bound. It's going to ask you for the left bound. So what I tell people is left and right get a little funky when you get these weirdly shaped functions. So I always say put it right on the answer you want and then hit the left arrow twice. 1, 2. Enter. So there's the left bound. Now go back to the answer, and now it's a right bound, so hit right twice. 1, 2. Enter. There's the right bound. And now the guess, I just put it right on top of what the answer looks to be, and I hit enter. So there's the answer right there, negative 3.19, blah, blah, blah.
It's like pi.
See again?
It's 3 plus 2 pi.
Sort of, I guess. It's sort of close to negative pi. And you do the exact same thing to find the other root. You can only find one root at a time. And it's really interesting if you happen to go further, a lot further. Anybody going to go to at least like Calc 2, maybe? A few of you guys, maybe even beyond Calc 3. If you take a course called Numerical Analysis, that just sounds evil, but it's not, of course. The one thing you actually learn is what the hell does the calculator do exactly to do what it just did? What is going on in there? And you actually do the algorithm by hand yourself. It's really neat. It's based on calculus. That's why I can't tell you right now. But it's called Newton's method, really. But that's why I give it a boundary so it doesn't kind of go outside of there. It knows the answer's in there somewhere, so it's going to keep trying until it homes in on it. Okay. So the other thing I want to do is solving an equation. So let's say I had an equation that looked like this here.
You want another one for that?
So again?
For parentheses?
Yeah, you do it the same way we did that first point.
Negative, it's 2.19258.
Cool. So if you want to look at that later, it's 2.19, blah, 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 blah. So if I had an equation that looked like this, let's see what's going to work. Does this work? Okay. Can you tell me why you might not want to even start trying to solve that by hand? What's the first step you pretty much have to do? Square both sides. If you square this thing, can you imagine? You have to FOIL this thing out with itself. You get a fourth power, dude. Good Lord. Right? So there's a lot of things like that, actually, that we just cannot do by hand. We can approximate, but if we want an exact answer, we have to do it numerically. And computers are able to obviously just chug numbers away until they get them to work out right. So what I'm going to do is, we already have this in y1. We're going to plug this into y2, and of course the answer to the equation is where the two graphs intersect. I love it. So if I just find the intersection of those two graphs, I can solve. You can do that with any damn equation you want to. It's just a really good way to check your answer if you have time on simpler problems that you can do by hand. Just check it real quick in the graphic calculator. So if we put into y2, square root, what did I say, x minus 1. Thank you. Sweet. And see how this picked it up? The square root of x minus 1 just moved it over 1. So in a couple sections, we're going to talk about transformations of graphs. How do I make a graph move over by 3, move up by 2? How do I shrink it? How do I stretch it? That's going to happen in a couple sections. One of my favorite functions on here is the zoom box function. So you see the answers right there. There's a lot kind of going on in here. So if I hit zoom box, that first option, what I can do then is if I start moving around, see my little cursor, dude? If I take it somewhere and hit enter, that's going to be one corner of a box that I can open up to zoom in on. It's a lot like Google Maps. You do that on your screen, you zoom in. So if I hit enter right now, that's one corner of a box. I'm just trying to make sure that I include that answer in there. If I take the other corner down to there, hit enter, it's going to zoom in on that spot. So I just can kind of see things a lot better. Is that cool? Let me do it again. So if I hit zoom 6 right now, it would take it back to the standard window. If I hit zoom box, I can move the cursor to one corner of the box and then move it down to the other diagonal corner of the box and then hit enter, and that zooms in. Yes, ma'am?
Do you think my calculator is old, or like whenever I hit zoom 6, it keeps doing this? I don't know why. That's what I did before.
Poor little dude.
I know, it's like freaking me out. Even when I hit this, like, I took the batteries out
Yeah, there's
before.
nothing in there. That's raw.
Even when it's just wrong.
Load is fine. Load is fine.
Just gotta be close.
That's weird. Poor
I
little
never
dude.
did that before. It's like dying and things.
Yeah, I guess so. Normally 84s they have extra memory and so forth. They should be good, but if it's pretty old, maybe it's...
Hey, Jeff, your TI Smart View is out of, it's old.
All right, Alex, I'll be all right.
It's because I got it for free from the TI site, and mine's colored.
Oh, colored lines? Oh, sweet. All right, I gotta look into that. Now, how do I find this intersection? Where do you think I go? Yeah, so all my stuff to do graphical analysis is under calc up here. This is all graph stuff. So I want to calculate something on my graph. So go second, trace, and then incredibly enough, it's the intersect. And let me try to get through the shortcut here really quickly. If I hit the up and down arrow, do you see what it does? It just bounces between the two equations. So it gets really frustrating when you're trying to move along the line here. It's not a line really, but anyway. trying to move on there and you keep hitting up or down and you're not getting anywhere, the left and right moves you on the graph. Up and down bounces between the graphs. With me? So if you only have one graph and you hit up and down, it ain't doing nothing. It's just sitting there like, what do you want from me? It's a little frustrating. So left and right if you want to move. So what this does, you see the questions it's asking. What's the first curve? Well, I'm on the first curve, enter. Now watch what it does when I hit enter. It bounces itself up to the next curve. So the next question is the second curve, enter. And then it says, what's your guess? So I go right to the intersection as close as I can get, enter. And then there it is, there's the answer. That's kind of crazy. That's neat. It has a nice answer. Now, so the shortcut for finding the intersection then is you hit second calc intersect. You can just hit the number 5 too. Put your cursor right on the answer and just hit enter, enter, enter. Because it bounces itself to the second curve. So you just put it right on the answer, enter, enter, enter. There you go. All right? So what is the answer to that equation?
X equals 2, y equals...
Now see, that's where I want. If only you stopped. This part has nothing to do with that equation. That equation is how many variables in it? 1. If I graph each one, they each have their own separate y values, but that equation doesn't look at it that way at all. It just says I want an x for an answer. So x is 2, that's the answer for that equation. Cool. Okay, so that was really quick. But I'm hoping it gave those of you who have never really used this before, hopefully this will help out. Right, as you do some stuff, you're going to, every now and again in the homework, you're going to hit ones that say, on your graphing calculator, do this. You better believe on the test, I'm going to say, on the graphing calculator, do this. And if I don't say that, do not use your graphing calculator to solve it. With me, don't say, I did this on the graph. I don't care. I want to see it. You can check it with the calculator, but don't do it unless I say use your graphing calculator. Okay, so any questions on that stuff? Okay, cool. So now, I just have a couple sections I want to do. Oh crap. Hey guys, feel free. I am not ashamed to say that I'm absent-minded. If the camera is not facing somewhere good, like at there, feel free to tell me. If it dies, tell me, right? Just keep me in track. I was meant to put that all on the video, but oh well, it's not there. So last time we got up through 2 at least. Let me see. Yeah, we talked about piecewise functions, vertical line test, stuff like that. So now the question is getting a little bit deeper into domain and range and other things that we can tell from the graph of a function. So for example, if I'm given this graph here,
What section are we in?
this is section 2, 3. Yeah, 2, 3. So if I'm given this graph here, can anybody tell me what the domain and range would be? What's the domain for this function?
Greater than or equal to.
From what to what?
1 to 4.
Yeah, from 1 to 4, inclusive, right? So what's the best way to write that?
In brackets.
Symbolic, I love it. So use interval notation. So domain is, of course, always about x's, or at least the input variable, which very often is x. Could be t for time, who knows? It's about the input variable y. Range is about the y's, or in general, the output variable. So really, domain, you never want to say from this point to that point. You want to say from this x value to that x value. It's the inputs I'm allowed to use. So from 1 to 4. And I want to include them because they're not open circles, right? And of course, what's the range? Same way, just for the other variable. Yeah, the first output I see is 0. And the highest output I see is 3. And they use all of them in between. So from 0 to 3. I said something that I've assumed already, but why is this a function?
Because it passes the vertical line test.
Yes,
Every input has an
it
output.
passes vertical line test, right? And what were we saying?
Every input has an output.
I love it. Every input has
One.
one output. I love it. So there could be only one. Cool. What else was I saying? Oh, where is this function? Oh, this is a little bit hard to tell. Yeah. Where's the give me one interval where it's increasing. Where is this thing increasing from to? What's the first place, the first interval it's doing that?
1 and 0.
1 to 2, I love it. So when I say where is something happening, that's the x value. It sounds like a note because it talks so slow. So when I say where is something happening, that's the x value. If I say what is happening there, that's the y value, that's the output. So where is it increasing? One place it's increasing is from 1 to 2. Actually, normally don't include the endpoints. Because at 2, what's it actually doing? It's just sitting there, right? It's not increasing or decreasing, it's turning. And where's another place where it's increasing? That's why I made it a little bit evil, but that's roughly going to be about, we'll say 2.5. Up to what?
3.
Yeah, up to like 3.5. Yeah. Cool. So you better believe on the test, I'm going to put a function like this. I'm not going to graph it by hand, thankfully. I'm going to use a little program that'll let me do this, and I'll put those dots in there so it's easy to tell where things are happening. You guys with me? So increasing is pretty simple. Decreasing would just be everything I've left out, really. You guys see how that's kind of silly? What's the first place I've left out here? From 2 to 2.5, right? So from 2 to 2.5, sure enough, it's decreasing. And then where else is it decreasing? Anywhere else?
3, 1, 5, and 4.
Yeah, 3.5 to 4 is decreasing. So pretty cool with that symbol there. I can't remember if I talked about that symbol. What's that symbol mean? Union, or even better, it's the word or. Or, because where is it decreasing? Here or there. Now in English, and would work, but in math, there is nothing that is here and there. Right? They're two separate things. There's nobody that does both. So we want to use the word or there. Oh, let's see, what else can I ask you? Oh, this is kind of, out of all this kind of came out. What's the max, and is there a min? And actually, there's two different ways we can talk about that. We can talk about a local max and local min. And what does that really mean? The local max would be sort of like, if you ever go hiking up Coles Mountain, you got the smaller peak right next to it. But they're both maximums locally. You have to go up to them both. One's a little higher, but who cares? So, how many local maximums are there? 2. There's this dude here. So things around it are lower than it is. And this dude here. Things around it are lower than it. Those are 2 local maxes. So what are the local maxes? Where are the local maxes? Let me ask you like that. Where are they?
1.5, 2.
Good. 1.5. Roughly. Well, it looks like 2. And at x equal to 3.5. What are they? For x equal to 2, y equals 2. And for x equal to 3.5, y equals 3. So when I say where is max min, you give me the x value. If I say what is the value there, what's the maximum? That's the y, that's the output, right? So y equals 3 for that. How about the min? Now these are kind of like trivially minimums, because they don't go anywhere from there. I don't know what they do next. If they kept going, maybe it would continue going down, and then they wouldn't really be minimums. right? So what is the true local minimum?
2.5.
Yeah, 2.5. So where would be x equal to 2.5? What is it? Yeah, like 1 point whatever. Again, if I put a problem like that on the test, I'd be careful about having a dot somewhere where you don't have to guesstimate what it is. Now, a lot of the stuff you talked about before, it maybe hasn't been given the names that we just gave it. Those are the official terminology we use when talking about this kind of stuff. Anybody going on into calculus eventually, this kind of thing is going to rule your life, and then you're just going to talk more specifically about how quickly is it going, how quickly is it falling, that kind of thing in calculus. Yeah. Okay, so any questions on that stuff there? So they're going to give you graphs, and they're just going to ask you exactly these kind of questions. What interval is it increasing on? Was it decreasing? Blah, 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 blah. Yep, okay. So let's do this. Let's try... Oh, good. Yeah, perfect. Yes, yeah. Let's try one out of the book here real quick. This is on page 169. Number 6. Let's start with number 6. Number 6, right there.
What page is this on?
Page 169. So part A gives people trouble sometimes because something I always have somebody tell me when they get a question like this is, they didn't give me the function, Jeff. What am I supposed to plug that damn thing into? But when you're given a function and you plug something into it, well, what do you do with that thing almost immediately? So if I give you a function and you plug something into it, so f of 3. When you plug a 3 in, what do you get?
2.
You get 2. I love it. So what does that mean about the graph of this?
The y value is 2.
It's going to go through the point 3, 2. The y value is 2 and the x value is 3, right? So I don't need the function. Somebody's already done all the work for me. I can just see where they put their points. So what is g of negative 2? What must it be? At negative 2, they went to 4, so it must be 4. Right? So they already did the work. I don't want the function. I'd rather just look at the answers. So what's g of 0?
7? Something?
Yeah, 4, 5, 6, 7. Yeah, it looks like 7. And g of 7? 4, 5, 6, 7. 4, yeah. Gotcha. Cool. 5, 6, 7, yeah. I hate when they only put one tick mark down there. What about part B? What's the domain of this going to be? What's the first x value that has an output?
Negative 2
Yeah, from negative 2?
to 8.
Yeah, 4, 5, 6, 7, 8. Yeah. So from negative 2 to 8 with brackets because they're included. They're not open circles there. What about the range? What's the lowest output that I see? 2 to the highest one? 7. So from 2 to 7 inclusive. Right, it's not too bad, right? I used to teach us walk the little dude on the axis. What's the first time he sees the graph? That's the lower value. What's the last time he sees it? That's the upper value. Same thing for the range. Now here, part C is different from part A. Part C, I don't know what the input is, but I know the output's got to be 4. That's for part C. Find the values of x for which the output is 4. So here's an output of 4. What value of x gives me that?
Negative 2.
-2,
2.
2,
6.
and 5, 6, 7. You can see the opposite. So part A said, here's x's, give me their corresponding y's. Part C said, here's a y, give me the corresponding x's. Does everybody see that? When you first see that kind of problem, it kind of freaks you out, but you should have seen that kind of problem back in 110. What about part D? Where is it greater than 4? I like this question. Where is it greater than 4? What we just figured out, it equals 4. Part C says it equals 4 at -2. Where'd it go? 2 and 7. 5, 6, 7. There you go, Jeff. All right, good. So that's where it equals 4. So it's going to be greater than 4 in between a couple of those, right? It equaled 4 here, and then it went up from there. So from here to here, it's greater than 4. So how do you actually answer that question then for part E? For what values of x is it bigger than 4? From what to what?
To infinity.
It's not always greater than 4, right? Like right here, is it bigger than 4? No. Right? All around here, it's not bigger than 4. Where is it bigger than 4? Starting where? -2. And now see, it's bigger than 4. And then right when it gets here, it's equal to 4 again, and then it goes below 4. So my first little interval would be from -2 to 2. That's where it's bigger than 4. How do I write that? Yeah, why parentheses?
It's not including the 2.
Because at that point, it equals 4, and it specifically says greater than 4. I love it. So I can't include those points. Hopefully. Anywhere else it's bigger than 4?
7, 8.
Equals 4 at 7. 5, 6, 7. So sure enough, from 7 to 8. Again, the same way. And what about at 8? Include 8, because it's still bigger than 4 at 8. Does that make sense? I mean, this is kind of building on stuff you know. Can you just read a graph? Can you see where things are happening? And do you know how to describe where those things are happening? So normally when I say where is something happening, your answer will be an interval or a series of x values. When I say what's the value, what's the maximum profit, that's going to be outputs. That's going to be y values. Yeah?
Why is one of them C's and one of brackets?
Because at these 3 positions, it equals 4. And this one specifically says greater than 4. But at 8, the output of 8 is 6. So I can include 8, because it is bigger than 4 there. There wasn't enough place to come back down again, right? So that it's still bigger than 4 at 8. That's a little technical detail that if you didn't catch, I wouldn't kill you. But it is an important detail. Right? It's not that difficult to see. I can't include anywhere it equals 4 because I want it to be bigger than 4. That's bigger than 4, I can include it. Hopeful. Alright, so what about a problem where we talk about let's see, increasing, decreasing, here we go. Number 22 looks pretty neat. I see all kinds of things happening. So try to write the intervals where it's increasing and the intervals where it's decreasing. Richard Acevedo. Richard Acevedo. Nora Hussein, are you here? Nora? The Don's here, right? Don? Yeah, okay. So just get that Greek now. Alright. So where's this thing increasing? Yeah, it's only increasing in one place, one interval, from -1 to 1. I love it. Everywhere else is going down. From -1 to 1. And basically when they ask you increasing, decreasing questions, you don't include the endpoints because either it's a turning point or this point's even freakier. It's just there's nothing really attached to it on the other side. So I don't even know what it's doing there really. So increasing from -1 to 1. And of course then it's decreasing from
Negative 2 to -1.
from -2 to -1. Or
Or 1 to 2.
yeah, from 1 to 2, it's also decreasing. I love it. Cool. Yes, sir.
Wouldn't increasing be in brackets since it's closed?
It's not, we don't, so this is a very fine point, and I don't really take points off normally if you include it or not. But at those points, I know they exist, but at those points, is it increasing at that point? You see what I mean? So if I'm climbing a mountain, if I'm on the side of a mountain, this is going to be a very strange example. It's too bad. If I'm climbing a mountain, and I'm right here, I'm climbing, right? As long as I'm not falling, I'm climbing, I'm good. So if some alien is chasing me, and they transport right here, and then they start climbing, at that point where they increase it, they weren't even there before that point. So I can't really say they're increasing at that point. That's where they suddenly start. And so at that point, they're just there. I can't include the endpoints, because I don't know what it was before that. Does that kind of make sense? It's a very fine point. That's why I'm not going to take points off if you put it in there or not. But normally we don't include them because I don't know what they were doing before. So I can't say they're increasing. Okay. So how's that? Is that decent for increasing, decreasing? It's really not that big of a deal for increasing, decreasing. Just remember, I don't want to see points here. I want to see intervals of x's. From this x to this x, it's increasing or decreasing. Okay, let me see if we give something funky. Oh, and then they have a problem like number, just to show you. Number 32 says find the max and min values. So how many maximum values does it have? 2. How many minimum? 1. So when we say maximum, we kind of inherently mean local max, local min. Is that the true minimum value of the function?
No.
Hell no, this thing goes to negative infinity in 2 places. But it's a local min, right? So this could be like a profit function for a company. So we could lose a lot of money if we're not careful, I guess. But I mean, here's a good place to be. If we can't get there, that's, an okay place to be anywhere above here. And that's a bad place to be, right? And obviously, here's a very bad place to be. Kind of with me? So you can graph profit functions for companies. In fact, financial analysts for companies. A friend of mine is a financial analyst. He used to be in Dell, and he got out of there just in time. They're tanking. He's working somewhere else, Select Comfort now, but it doesn't matter. So he analyzes all the factors that go into the price, and he says, you should set your price here, because I think this is going to get us closest to the maximum profit we can make in this environment. And then the next day he says, okay, things have changed. Let me change my equations. You should set the price here. I mean, that's one thing that they do, is they constantly try to find and get to the peak of a profit function. All right, it's a little more complicated than that, but it's basically what they're trying to do. Okay. A little preview, And then I'm planning on letting this out a little early, if that's all right. The next section is one that I'm actually going to show my calculus class tonight. Because it's, before we do that, let me show you this. And in fact, even before we do that, so when you're traveling around San Diego, especially at certain times of day, your average velocity can be quite different than your maximum. So you round the corner and then all of a sudden traffic stops, right? So if you start at 2 p.m., and you end at 4 p.m. And at 2 p.m. you are at position 10, let's say. So we got this like this route. Maybe it's going to be a race route. So we have those. So we're here, position 10 miles down the road. And at 4 p.m. we're at position 70 miles down the road, right? And away from the start. Okay, you guys still with me? So anywhere in between, do I know how fast I was going at any specific time? But I can tell you how fast I was going on average. Right? To find the average rate of change, the average speed in this case, what would you do? How do you find speed? What's the rate? What's the general equation for distance, rate, and time? Yeah, DERF. Distance equals rate times time. So the rate is distance divided by time. And how far did I go? 60 miles. Good. So 70 minus 10. And how long did it take me?
4 minus 2.
Yeah, 4 minus 2 took me 2 hours. So I went 60 miles in 2 hours. So overall I was going